Okay, so thank you very much for the warm words and the introduction, and it's a pleasure for me to be today here. So it's the first time for me being in Korea. So it's one point, and on the other side, I'm happy to be part of the Future Mobility Seminar of this year. And today I want to give you some overview and insights regarding the approval of connected and automated vehicles in Europe and in Germany. So I will go through a short introduction. Yeah. So what will the presentation be about? So first we will have a short introduction. Afterwards I will go through the regulations, give an overview, what are the insights and what are they defining. And after this, we will go through the type approval process in general, and then regarding automated driving systems, focusing there on the ALKS system, and afterwards on the AD level 4 European regulation. And closing will be then the last part, because it's not clear that when you have a type approved vehicle in Europe that you are allowed to operate such a system on public roads with an AD functionality. Normally, we start the last years always with one of the two slides, our presentations, because the story there was that legislation and standardization has to do some base work and to give the legal base to bring such system on public roads so that technology can operate it there. And since last year, we have a big change. So technology gets, so we have the shift. So in the last years, the gap gets smaller and smaller. But now we have the shift in Europe. So since 2022, we have two regulations regarding level 4 automated driving in Europe, and there's since 2021 the ALKS regulation is in force, and we have an update since since this year regarding ALKS, so the 01 amendment, and now we recognize there's a shift that standards like ISO 21434 for cybersecurity and the standard for software updates, but also, for example, regarding UL 40600 in the US, they could give a guidance how to bring the documents and how to bring the proof of state of the art. And since last year, as already mentioned, we have the regulations right in place. So today I will focus in the presentation on the regulation part. Since a couple of years in Europe and of course also since a couple of years we have very much experiences regarding pilot projects, showcase projects for automated driving, regarding robotaxi, delivery vehicles or bus shuttles. But they are all based on an individual vehicle approval. So I think my colleague Martin Unterhauser will get more in deep in his session on this topic. But there's the question, why don't we see the systems now in series-produced vehicles or mass-produced vehicles? So besides the big question we know from our customer, what could be the business case for such technologies, and the point that the necessary components and development phases are very time and cost consuming. There are some additional ones they are dealing with. So I just put some of the challenges on this slide. So for example, besides the business case challenges, there are, for example, regulations they have to deal with regarding the compliance with traffic regulations. So by an ODD getting more and more complex, it's very difficult to bring the proof that the system is able to be operated safely on public roads. Or for example, when you say my ODD cover, for example, urban areas, but also highway areas. So you have to show that you are compliant with traffic rules, and there's a difficult, there are directives and laws in place, but there are also some difficulties that it's not only the law and the directive, so you have also some decisions done by judgment or some common behavior. Another challenge would be then, of course, to show that you have considered all possible hazards and risks in your operating area. And it's not only the hazard and risk coming out from the safety concept, like unbehaved, steering failures, braking failures, or something like that. So here you have also to consider, for example, events in public events. So for example, when you take Munich in September, they will start the Oktoberfest. So you have also to handle these events in your ODD, and so you have some other risks to be considered. Another one, it's ensuring a smooth traffic flow. It sounds first very easy, but in combination with the point of compliance with traffic regulations, and that the point that the most human drivers doesn't handle very often regarding the STVO, for example, the traffic rules, you have to think about how could I bring the proof that my system is able to be operated smoothly and don't disturb the traffic flow. On the other side, it's very tricky to get the overview, what are the tests I have to perform, and also the point, what are the scenarios, and have I covered all varieties of the scenarios. So here it's very tricky for the most of our customers, and how to use and what kind of test methods are to be used to be on the other side trustworthy and reproducible. So there's only just an overview of the challenges. So now I will go through the regulations and give us a short overview. So where are we standing now regarding the systems? So we are now between level 2 and level 3. So the first systems called level 2 plus are in the market. There are some test vehicles already operating in Europe regarding level 3 and level 4. But what we missed now is the first applications for level 4 systems. LKS is the first level 3 system available and type approvable from UN ECE. So we have the possibility to bring such a system in all contracting parties which accept the UN R157. And the system in the first stage was about maximum speed to 60 kph, only taking over the longitudinal and lateral movements in one lane. And there are a couple of requirements to be fulfilled by the manufacturer. For example, there are functional requirements for the systems, there are required state transitions. You have to ensure that the system is able to be operated within 10 seconds after a transition demand, so in the effect of an event. So the system has to be able to be operated 10 seconds more safely. There are also some pointers in the regulations to be compliant regarding the data storage system for automated driving. So this is the system recording who was responsible for the driving task, and the EDR, so the event data recorder, it's similar to the black box of an airplane. So it records everything in a specific time frame, what happens and what was the reason and what was the status of the system. Then you have to be compliant with the 155 and 156 for cybersecurity and software updates. And then there are some major points which will be then also assessed during the approval process. So we have the complex electronic systems. Here you can find the requirements regarding functional safety, operational safety, the possibility to use as a test method during the type approval process of simulation, but also then in a special or in an additional annexes, you will find the test cases for the ALKS homologation. So there are some mandatory scenarios, but there are also some requirements to perform, for example, the real-world testing. So for us, it was by publishing the 157, the first point, so where we think it's possible to have this turn off, so to have the first automated vehicles on public roads. But as we see, there are only, from my side, known two systems approved by manufacturers. So the one is Daimler, the other one is, I think it was Honda in Japan, having these systems available for the end consumer. And there's the question, why didn't we see the systems more often in the vehicles? So the first point we get is a business case and the effort for the type approval. But the new amendment of ALKS, so it was published in this year, changes many things regarding the performance of the system. So it's now allowed to a maximum speed of 130 kph. There's also the possibility for M1 and N1, so passenger cars and light commercial vehicles to operate a lane change. And of course, you can also use ALKS now in heavy vehicles, so in the M and N. But there's a limitation that these vehicle classes are not allowed to perform lane changes. So besides level 3 regulations which are now in place, there's two additional ones. So the first one is in Germany, so it's called the AFGBV. It's a directive for the type approval, the national type approval of level 4 vehicles in Germany. But here you will hear the details by my colleague, Martin Unterhauser. With the mandatory date in July 2022, there are many ADAS systems to increase the safety in the traffic, mandatory by general safety regulation, like the intelligent speed assist, or the driver drowsiness and attention warning. And these are all systems and assistance systems who helps to develop and gain experiences regarding assistance, but also regarding automated driving. Shortly after the AFGBV in Germany, the European Commission published the Directive 2022/1426. So it's a directive for fully automated vehicles in Europe, which gives the possibility to type approve small series in Europe, so for all contracting, so for all countries within the European Union. And for that, I will go now on the next slide to show you some more. So here you see what is the regulation defining. So here you see the 3 use cases defined and scopes of the regulation. So it's possible to type approve shuttle and goods mover. So it's operating such vehicles in a specific geographical area. The other possibility is to have a use case, for example, for the hub-to-hub transport, which is more addressing, for example, the heavy vehicles, but also buses or something like that. And on the other side, this is one use case for the individual vehicles. So for the normal end consumers, it's automated valet parking. So here's also the possibility to bring such vehicles type approved with these features on the market. So it's related also to the regulation 858, so it's a base regulation for the type approval for M&N vehicles, and there's the link to the general safety regulation, so that it's the regulatory base to bring such vehicles on public roads. So the main puzzle pieces of the regulation are, so you find requirements regarding the performance of the system. There are also requirements you have to fulfill regarding functional safety and SOTIF. So there will be an assessment and a safety management system audit. We will have some slides afterwards, some more details regarding that. There will be also, could be found the requirement and link to be conformed with UNECE 155 and 156 regarding cybersecurity and software updates. And there's also some described testing, so on proving grounds, but also on real-world testing. And additionally, there's some requirements regarding how to monitor the systems during the operation and how to report it over the life cycle. The main difference between the German directive and the European one is, so the European one is limited to the vehicle classes M&N, so passenger cars and commercial cars. There's a possibility to bring in virtual methods, so like simulation, and to compare them with the real world. You will also find some requirements regarding the PTI, so there's also a link to regarding the periodical technical inspection, so you have to show to technical services and approval authorities how to test such vehicles in during operations. And the possibility, so it's one main change is that you can use a multi-stage approval, so you can use a basic vehicle and then set up an automated driving version. Regarding the approval process, so here you have 3 steps, normally in Germany. So you have to do the vehicle type approval, for example, by the approval authorities, the KBA. The next step then would be, and this is the difference or the most challenging point for customers and manufacturers in Europe, how to bring such vehicles on the road so that you are able to operate the systems. So this will be then step 2. So in Germany, you need an approval of the operating area. In Sweden, in comparison to that, the Swedish government will say the places and areas where you are allowed to operate such systems. Or when you take, for example, Spain, Spain always says, okay, you can operate automated and autonomous vehicles, but it's not allowed to activate the systems, for example, in tunnels. So regarding the federalism in Europe, there are some difficulties for the manufacturers to get this overview, what has to be considered and what are the limitations and boundaries to operate such a system. And the last step then, of course, would be to go to the local authorities to register the cars. So now I want just to go shortly through the type approval process to give a first short overview, how does it look like. So the main difference is in Europe, we are here in the type approval and not like in the US in the self-certification market. So here we are more testing in front of bringing such vehicles on public roads, and you have a third party in place, and by self-certification it applies to the manufacturer to bring the proofs and documentations. The main difference is in the effort and in the time. So it seems mostly that the effort will be more huge by the type approval in front of starting of sales. But for self-certification, it could happen that the effort will increase later on when there are some later tests or, for example, mark surveillance inspections. So how does the process looks like? I have took the example of Germany. So in the first step, it's necessary to clarify the legal base for the approval. So that you have to use, for example, for M vehicles, the regulations, the European regulation 2018-858, which defines all steps and systems to be considered for the whole vehicle type approval. Afterwards, when going more in depth regarding the systems or the system approval, there will be they will look what is the specific regulation to be considered and to be tested, for example. Afterwards, there will be the preparation of the approval documents and the review of such documents. And based on the test report and the delivered information by the manufacturer, the approval authority, for example, the KBA in Germany or the RDW in Netherlands or the VCA in UK, then will decide on the approval. And then when all requirements are fulfilled and the tests are done, the approval authority will grant the operating license and the type approval. And the last step would then by the owner be the registration. So what is the relation between the legislation, regulation, and standardization? So on the first, UNECE, for example, defines the requirements and the tests and the procedure, for example, with 155, 156, or 157 for ALKS. Afterwards, the European Union, for example, here as a contracting party of the UNECE, has to adopt the rules and directives for the European type approval. And then the national, so the countries like Germany, Netherlands, French, they have to implement the regulation to the national ones. And then there will be the third party for the type approval process. It will be the delegation to the type approval to perform and execute the process. And the standards builds for the manufacturers the possibility to create the evidence and proofs according to international accepted requirements and frameworks. Here we see the steps for the type approval and how does the stakeholders and the roles. So in the first, you have the manufacturer who submits the application. On the second step, then there will be the approval authority to perform the initial assessment. So when you're not already listed as a manufacturer, this would be then step 2. Step 3 will then that the manufacturer choose his technical service, whom he will then do the type approval. The manufacturer then prepares the information documents, which has to be then delivered to the approval authority, but also to the technical service. And then in step 4, the technical service will inspect and create the test reports and will complete the documentation by this test report. And based on the delivered information and the test report, the approval authority will check this document package, and then when everything is fulfilled, will grant the approval. In the last step then, the manufacturer creates a COC paper and will perform then the conformity of production tests and so on. So the regulation 858 also defines the roles. So on the one side, we have this Article 3, who defines who is responsible for the approval of the systems. So we have the approval authority, which is responsible for all matters of the type approval, with the withdrawal of the approvals, and as a contact to the other European countries, for example, for ALKS, it's necessary to have these discussions and exchanges for the operational design domain and the operational area. In the next, so in Article 13, you will find all definitions for the manufacturer. Means what is his obligation. So he has to ensure that all requirements of regulations are fulfilled. He's responsible to perform and monitor the conformity of production, and he has to ensure, for example, by emission, that there are no defeat devices in place. In Article 30 of the directive, you will then find also the definitions for the European type approval and the tests who has to be performed. So there's on the one side, you have the European type approvals, the authority reviews. So normally that's the tasks which has to be performed by technical service. So what kind of approvals there are in place regarding 858? So of course there's on the main part, the whole vehicle type approval. Then there's the possibility to approve also systems, like braking systems, steering systems, or for example, the automated lane keeping system. Then, of course, the components, or one exotic one is a separate technical unit. So, for example, here with the underrun protection or the windshield. But now going more in depth in the automated driving type approval process. So normally you can say by the AD system, you're defining the operational design domain. By defining the operational design domain, you will come to the point that the ODD will set your requirements to be fulfilled and what kind of scenarios has to be tested. And with the ODD, so here you see the boundaries, so the requirements and the scenarios. And then during the approval process, a third party or the approval authority will check them regarding 3 pillars. So it's very similar to the new assessment test methods, which are worked out and defined by UNECE since 2018. So there are 2 main pillars. So you have a testing part and an audit part. In the audit part, there will be performed a safety management system audit, which will have to be done on the first stage by the manufacturer. And then there will be a second audit, which will be done then by a technical service. Then we have the safety assessment. So for the complex electronic systems, where we look on functional safety topics, SOTIF topics, cybersecurity, software update processes, but also regarding, for example, your function description. And then we will go through the testing parts. So simulation is allowed to be used by the AD system in ALKS, but also in level 4 as a test method for your testing or for your safety concept. On the other side, there are some mandatory tests defined on track tests or proving grounds. And then one additional point is that it's necessary to perform with such vehicle systems like level 3 and level 4 real-world testing. So it's necessary for the manufacturer to be ready in the 5 disciplines regarding here. So, and for example, using ALKS, Annex 4 of the ALKS regulation will define and describes the requirements and tests or assessments to be done regarding the vehicle and operational safety, but also regarding functional safety and SOTIF. In the core text, you will find them in ALKS, for example, the requirements that you have to be conformed with cybersecurity, but also when you're using software updates. And by using virtual methods, you have to show to the technical service the validity from your used simulation tools, but also the used models. And then Annex 5 and Annex 6 of the current version of UNECE 157 for automated lane keeping describes all requirements regarding proving ground testing and real-world testing. So here on this slide, I draft a bit the main pillars for the type approval, as we already heard on the last slide. So here is the main, or the fundament will be the audit and assessment part. The simulation is one puzzle piece. So here you will find So here we will perform an audit on the development processes and the V&V strategy, but also regarding an assessment regarding the safety concept. Here is the important point. It's not only functional safety, so it's functional safety, operational safety, SOTIF, and additional topics. Then when you use simulation tests, we will consider the test results when we have the trustworthiness regarding the simulation. And then, of course, there will be some measuring process. Afterwards, we will have some proving ground tests. So this will be the validation of the audit assessment results and also the performed mandatory scenario tests, for example, described in Annex 5 of the regulation. And here the main point is that the reproducibility is given. And then afterwards, there will be the real world testing, which gives the possibility to validate and verify the behavior and the safety concept from the safety assessment. Now we want to go through the single or the main pieces of the type approval of an AD system. So here you see the ALKS I used. So here we will now focus on the next slides on the complex electronic system, so regarding functional safety and operational safety. In the core text, you will find the requirements regarding the ALKS. So just shown some examples, like, for example, the human-machine interface. So there are requirements regarding how to activate the system, how to show the availability of the system, or, for example, when you are overriding the AD system. Then there will also be some requirements so that a manufacturer has to ensure that there's no possibility of misuse of the system and to be conformed with the traffic rules. So for that, we will go then in the type approval process regarding through a document check, so a document review. By the next part will be then the safety management system audit, and additional then the verification tests for the complex electronic system part. Output will be then a report by the technical service for Annex 4, for example, but also then in addition to the whole 157 approval. And then, of course, there will be the necessity to show the conformity to 155 and 156 for cybersecurity and over-the-air updates. So going to the audit, so normally how does the process looks like? So we normally we take, so initiating the audit means to clarify with the customer the requirements, the corporations, the timing, the accessibility of the informations. Then there will be also the preparation phase where we define the audit team on technical service side, but also on the customer side, who will be audited and what will be the audit plan. And this will then be concluded by an alignment. Then the execution of the audit, it will be mostly a time duration of 3 days, what we need. So here we have a preparation phase, so where we review the documents, the delivered documents. Then there will be the execution on site by the manufacturer, and then there will be the conclusion regarding the findings, or hopefully no findings. The closing and completion will be then that there will be a closing meeting, the summary to an audit report, and then, if necessary, there are some follow-up measures, and in case of subsequent audits, keep in touch for further plannings. So normally, during the surveillance, there will be the main audit regarding safety management system in the first year, and each year behind that, so second year and third year will be then the first surveillance. So it will be a document review, and afterwards there will be then again a main audit. So document review, so the safety assessment. So here the process looks like. So we have the scope definition, for example, for ALKS. Then the checklist will be prepared. We will request some information from the manufacturer. After the handover of this information, we will go through the checklist, draft a report, then discuss it with the manufacturer or, for example, with the applicant. And afterwards, after clarifying the findings or the result of the assessment, we will write then the final report. So the main efforts lay with the document-based assessment of the safety concept, so from our experiences. So the next main topic in the complex electronic system annex, so Annex 4, for example, will be simulation. So, and one difficulty for the applicant is, for example, that he has to show that his system is similar to a human driver or better as a human driver. And when you here see some figures from 2019, so for example, in the US, the traffic jams or the fatalities decrease for 2% from compared to 2018. For example, here, when you look at Europe, here we have estimated 23,000 road traffic fatalities, and almost means 7,000 fewer fatalities compared with 2010, and compared to 2018, it is decreased also for 2%. And for example, in Germany, we have in 2019, 3,000 people died in road traffic accidents, what means it is the lowest level for more than 60 years in Germany. And as you see here, the figures for fatalities decreasing year by year, and this will increase the requirement and the challenge to be handled by the system. And this will also multiplied by the mandatory ADAS system, so it will be more and more difficult to show the proof that the system is better than a human driver. So normally looking at the simulation, so it's a KPI-based evaluation of the positive risk balance. Here for the first, for example, you have the scenarios. For example, here a cut-in scenario. You have to show then in a setup that your simulation is quite similar with the red line, so the test track. And then you can go through all parameters and situations, and then you have the possibility by simulation to show that, for example, your ALKS system is in all points better than a human driver. So this means these are the results of a human driver for the same scenarios, and you have this for the ALKS system, and in comparison, it has to be shown that the ALKS system is similar or better than the human driver. So here, I put together the virtual validation at a glance. So the challenge from regulation coming is so that the complexity of the system, AD system or ADAS systems, get more complex by the technology. The traffic situations are a huge number to be considered, and how could you certify the safety of the systems? So the solution could be to use a scalable testing with scenario-based, but using only physical testing will increase your amount of effort. For that, it is that you have the virtual driving tests as a complement to the test track and the real-world testing. So the legal aspect is that the virtual validation gets mandatory or usable in the regulations. So, and you have to be compliant with your tools regarding the regulation and the agreement of 1958, so the Schedule 8. And then you have the special provisions from the approval authorities, but also, for example, regarding the ALKS regulation. So here's a virtual method. So there's a regulation gap, so a challenge by using simulation. So on the one side, you have the safety concept. So ALKS defines in Annex 4 that you can use simulation as a test mode. So you have to be in line with the Schedule 8 of the revision, and you have to demonstrate to the approval authority or the technical service that your tool and your used models are valid. So means that you have to show a simulation tool qualification or model validation. And by using the positive risk balance, here you find, for example, in the Appendix 3 to the Annex 4 of the ALKS regulation, that the conditions under which automated lane keeping systems shall avoid a collision are determined by a general simulation program. So the challenge or the problem is that there are no standards, guidelines in place for model validation and tool qualification yet. So this is one challenge to be covered in the next time. So one way would be and could be so the simulation credibility assessment, which has to be performed then by the manufacturer and then will be reviewed by a technical service, and then also the correlation between physical testing and the simulation will be then be reviewed and inspected by technical service. So what is included in the simulation credibility assessment? So you have to show and assess the model and simulation management. You have to go through your analysis, the verification and validation. So jumping to the next topic, it's the testing. So here on this one slide, you see Annex 5 and Annex 6 are describing ALKS proving ground and the real-world testing. So what is the main difference between the both? So you can test criticality tests under controlled conditions on proving grounds, but not on the real world. Is it possible to have deterministic test results on real-world testing? Not, or very difficult, because you have some to safeguard that it's always the same situation under real conditions, and on proving grounds it's not a problem to have such test results. And some the multidimensional real conditions you will not be able to bring on that proving ground. So for that, this is the advantage of the real world testing. So here I brought some equipment pictures from the colleagues, how to test such AD vehicles on proving ground and what's necessary. So and here you see also what has to be tested, for example, on the proving grounds. So you have some checklist tests and conformity assessments. So and other ones are the described scenarios in the Annex 5, but also additional ones coming out from the Annex 4, for example, from the safety assessment. So jumping now from ALKS level 3 system to a level 4 system, how does then the process or the procedure looks like by using the example of the European regulation for level 4? So for that, you need, on the one side, of course, a designated technical service for the scope of level 4. So taking, for example, Germany as an example, there are only 3 technical services in place. So, and TÜV Süd was one of the first getting this designation. So, and what is the process looks like? So, in the first time we have, of course, like already described, the application, then the initial assessment or the initial inspection as a manufacturer. So there was the first discussions if the requirements to be fulfilled by a manufacturer are different to the conventional initial assessment, but this discussion has been ended so that there are no changes. So they will include the additional requirements for the manufacturers in the safety management system audit. Afterwards, there will be then the check and the test, so the document reviews, the audit safety management system, then the safety assessment reviews, the conformity check regarding cybersecurity and software updates when using software updates, and then of course the mandatory tests or spot checks regarding physical testing. After going through these points, then there will be the conclusion and preparation of the document package to hand over to the approval authorities, and then afterwards, for example, in Germany, the next step after granting the type approval of the system will be then the approval of the specific operating area. So the last slides we went through in the presentation, we went through the step-by-step through the approval process for a level 3 system. And as you can see here, the process and steps are mostly similar to from L4 to L3. So you have the safety management system audit. You also have the safety assessment of the vehicle system compared, and in addition to that, there will be some, when you use a simulation, you have to validate simulation tools and the used models. And in the last steps, there will be the physical testing to be performed by technical service and approval authorities on the proving ground, but also on public roads. So one of the main questions from our customers is my ADAS AD function safe? Is it safe in all possible situations in an ODD? So did I consider all traffic rules, traffic signs, infrastructure, possible infrastructure, and the weather conditions? So this is what has to be done by the manufacturer or the applicant is he has to analyze his ODD. So and in the first step, it will be very easy for him to split it in known safe areas and known unsafe areas. But it is sure that then there will be also areas, so unknown safe areas and unknown unsafe areas. But how to bring this number of unknowns more and more to a lower number? For that, you have to think about your scenarios, multiply it with a distribution of possible scenario parameters. But then you can decrease the number, but it will be not enough. And after that, you have to calculate, and how to calculate the residual risk in the unknown areas. So it's only possible to reduce the unknown areas by creating additional potential hazard scenarios. And to create the potential hazard scenarios, you will need to mix the known scenarios. So for example, cut in, cut out, following a lane, with the triggering, known triggering events. So what could be a triggering event? Could be, for example, cyber attacks. It could be the loss of connection in the ODD. It could be a football on the street, for example. And so you will decrease the number of unknowns. And afterwards, the next step would be then to use the ontology of scenarios. So to use the ontology-based creation of synthetic scenarios. Here you use a database, and here you are multiplying the known scenarios and hazard scenarios by the distribution of scenario parameters, multiplying this with difficult, for example, difficult weather conditions and real conditions possible in your geographical area. And then you're multiplying this finally with potentially dangerous triggering events. And so you can bring the number more and more on a lower level. So you can also compare it like with a dinosaur, so from the head to the tail. So in the first steps, it's more and more easy to decrease the number, and then it will be more and more difficult to find the unknown areas in your ODD. So one additional point, so I mentioned in the front, so it's the advantage of the European type approval. It's a multi-stage approval process. So here you have the possibility to use a base vehicle, so you can use a already type approved vehicle, and then take this type approval and add a second stage, or so you can then apply for the second stage with the ADS functionality or AD system, and the advantage is then that you only have to retest, for example, systems which are affected by the AD system. And you need then, of course, as a second stage manufacturer, the connection and the cooperation agreements between both manufacturers. The only thing, or the challenge here is, for example, regarding cybersecurity, you have the necessity to, so the first stage vehicle manufacturer has a cybersecurity management system regarding design and production. And now when there's a second stage manufacturers, then there will have to be performed a joint project, so to rebadge the cybersecurity management system certificate, so to consider and cover every possible threats and management system. So it has to be ensured that second stage manufacturer has the possibility to, for example, to know cybersecurity attacks or potential risks and threats. So on this slide, I just put the main, so what has to be retested and what could be retested. And for example, in red, here you can just transfer, for example, the system approvals to the second stage. So the challenge here is more for the second stage manufacturer in defining this collaboration and contract agreement with the first one. So to have the guarantee to get as a second stage manufacturer all needed information, and to be, for example, to have the information what could be, for example, the boundaries and specifications of the vehicle. And here's the one question is, or the main challenge is the challenge regarding roles and responsibilities. So what has to be handled by the first stage manufacturer and what has to be performed or handled and done by the second one. So coming to the last chapter of my presentation today is the operating area approval. So this is one special thing, for example, for Germany. As I already said, in Sweden or in Spain, it's different defined and there are different laws. So what will be the process? So the main change is that the stakeholders are different. So for the approval of the operating area in Germany, it's not the manufacturer who is responsible for, so it's more the vehicle owner. So who will then operate later on the vehicles on public roads. And approval authority will not be the KBA, for example, in Germany, who's responsible for the vehicle type approval. Here it's the responsible state authority for where the ODD or the specific operating area is located. So, for example, in Germany, you have the highways. This is a federal authority dealing with this topic or is responsible for the infrastructure. And then, of course, you have the different 16 states in Germany you have to handle and go through the approval processes. What will be done? So in the first stage, there will be checked if there's the used vehicle type with the AD system has an approval. So does the AD system or the AD vehicle, so the AV, fits in the specific operating area? Are the personal and material requirements fulfilled? So you need for the operating of an AD system a technical supervisor, for example. No safety driver is necessary, so you need just one guy who is monitoring the whole time the AD operation. The next one will be are the additional conditions. Do we need some? For example, as I said, in Munich you have now the Oktoberfest starting in a few weeks. So here it could be that authorities then set some additional requirements to be handled. And for that it's very challenging for the applicant, who is now the owner of the vehicle, to get this information or to implement the requirements. So he has always, or he needs a contact with the vehicle manufacturer. And afterwards there will be some real-world testing in the specific operating area, so that the smoothness and the road traffic rules are considered and the AD vehicle is conform. So here you see the process in some more details. So here you have the vehicle type approval with the AD system has to be available. Then you need the vehicle owner has to apply for the approval of the operating area. So then the authority will check, and the technical service could the system or the automated vehicle manage all driving tasks in the operating area. So it will not go so deep like in the vehicle type approval in the details of a safety concept or a function description. So here it will only be a check, does the operating area fits with the ODD and the performance of the system. Then are all infrastructure requirements and technical requirements fulfilled, or is there a need of modifications or some adjustments regarding the ODD or the operational area? And if this could be confirmed by the assessment, the approval of the operating area will be granted by the responsible local state authority. Otherwise, here you have always the loop back. So on the one side, to adapt the operating area, and when this is not possible, you have to jump back to the ODD of the vehicle to have some updates regarding the ODD or the AD vehicle type approval. So looking on the time and on my slides, I think I'm at the end of my presentation. As many thanks for listening, and I hope I could give some introduction regarding AD type approval in Europe, and especially some insights and some challenges. And if there are any questions, please feel free, or afterwards in the break session.